Oh, sweet, sweet, sweetness. I am so excited to be starting a unit from the 403 to the HAZ. I am Mr. Nelson, and it is a early dismissal day, so I'm a little more peppy than usual, because usually by the last hour, my class just takes it out. It takes a lot of it. We are talking about exponential function transformation, you silly Nelson. Transformations. Okay? And guess what? What? I'll tell you what. Tell us what. They behave, exponential function transformations behave very similarly to just regular, well, they identically, but in their own way. So we know that for a regular function transformation, it looks like this. B x minus h plus k. K, 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 k. And, as I tell you in every video, A and K, they are transformations to my y coordinates, whereas B and H transform my x coordinate. And that is true across all transformations. So when we're doing our radical equation transformations, it works the same way. Just the equation looks a little bit different because now it's specific to radical equations. This is specific to all functions. And then we can actually look at each individual type of function. So this is our radical function. X minus h plus k. So, again, these behave the exact same way, and we'll kind of go to it. Where we know that this is why I love making these videos, is I get to talk about the same thing over and over and over and over again. So, let's do it one last time. Hopefully this is one of the last times I'll have to do it. But hey, I love this. I love this. Quit whining, Mr. Nelson. So A, regardless of what transformation it is, and listen, let's just do the, no, we're not going to do it just, well, shoot. Shoot. We're going to do it quickly, okay? A is my vertical stretch. So, if A is a number, if A, the absolute value of A is bigger than 1, it's going to be a stretch. If the absolute value of A, if basically just the number regardless of the sign, if it's a number between 0 and 1, it's a fraction, we're going to get a compression. We're going to get a squeeze. It's going to make it smaller across the y-axis. And then if A is negative, we get a reflection in the x-axis. It reflects in the x-axis. Okay? That is really the most important thing we need to know for A. And then B is like A's evil twin, cousin, uncle, brother, because it is a horizontal, it's horizontal, this should say stretch, vertical stretch, or vertical transformation, horizontal stretch. But with B acts a little inversely. So if the absolute value of B, regardless of its sign, if it's a number bigger than 1, it's going to be a compression because we actually stretch using B by a factor of 1 divided by B. Okay? So if I have a B of 2, I'm going to multiply 1 divided by 2 by all my x coordinates. And then if B is negative, we have a reflection in the y-axis. Okay? If B here, if the absolute value of B is a fraction, going to be the opposite of A. It's going to be a stretch. And then, so we always apply our A and our B's first. We always multiply by A or by B. We always do the A and the B first, and then we add or subtract our H's and our K's. So we're going to just work with table of values, and we're going to run with it. But let's talk now that we've revised this. This is my probably third or fourth time talking about this today. It's fantastic. It's fantastic. So, now let's talk about our exponential function, okay? And our exponential function transformations look like this. Very similar, but kind of different in the way that they look. So I've got A, C is a constant, to the power of B times X minus H plus K. And guess what? A, B, H, and K all behave exactly the same way. Okay? We apply the transformations the exact same way. Now, just like the baseline function that we are going to transform for here, we started at f of x, and then we did all these transformations. Here, we start at y is equal to the square root of x. That's our baseline. That's what we apply all the transformations to. And here, our baseline is y is equal to c to the x, where c is just a constant. It's just a number. It's any number, but it's going to be a constant number. It's going to stay that number. Okay? So, let's start playing around with some transformations, okay? But basically, when I start looking at, well, we'll jump into it. I'm gonna erase this, and I'm gonna move my exponential transformation over here. Okay? Now, exponential functions behave like parabolas. Well, they behave parabolically. So I got b x minus h plus k. Okay? So, let's imagine that I give you a function transformation that looks like this. Okay, we're going to do, let's say I give you y is equal to 2 to x minus 2 plus 2. Okay? Whatever has the exponent, whatever base number has the exponent is going to be my c. So in this case, 2 is my c, and my reference function then, in this case, is going to be y is equal to 2 to the x. I'm replacing that constant with 2. My constant is 2. So this is my reference function, and I'm going to make a table of values for this function. Okay? I'm going to do x and y. X is I'm going to go from negative 2 to positive 2. It's just kind of my go-to when I can. And then I'm going to calculate y by doing 2 to the power of that. So 2 to the power of negative 2, if I remember the exponent laws, I know that I can make that exponent positive, because this is an invisible over 1, by flipping this. So I can go 1 over 2, and then that exponent becomes positive, and I can rewrite that as 1 over 2 squared. So this becomes 1 over 4. 2 to the negative 1, I can rewrite, well, that's the same as 2 over 1 to the negative 2. I can rewrite that because I know that I just have to flip it. If by flipping it, I turn that exponent positive. So 1 over 2 to the 1. Flipping it makes the exponent positive. 1 to the 1 is 1, 2 to the 1 is 2. So this is going to be 1 over 2. Okay? Any number to the power of 0 2 to the power of 0. Any number to the power of 0 is 1. Okay, and then 2 to the power of positive 1 is just 2, and 2 squared is 4. Okay, so we go 2, 4. And if I were to graph this chart, it would look exponential. Surprise, surprise. So this graph would start at -2, a quarter, and it would kind of just go like this. That's ish what it looks like, right? And this would kind of just keep going and approach 0 over time. So in this case, I have to, like every time I'm doing a transformation, I have to figure out what my A, B, H, and K is. And I look here. Okay, what is the number that's being subtracted away from X? That's H. And H, remember, H and B are different. They behave opposite. So if this is -2, my H is +2. I'm moving to the positive X direction. And then I'm adding a number to all this, and that's going to be my K. So in this case, I'm just doing a vertical and a horizontal shift of +2 in each case. So what do I do? Well, H's are going to transform my X coordinates, K's are going to transform my Y. I'm going to make a new table of values here based on my baseline function. I'm going to call that X prime, Y prime. Now, let's start with X. All I'm doing is adding 2 to each X. So -2 plus 2, 0. -1 plus 2, 1. 0 plus 2, 2. 3, 4. And then the Y, I'm doing the exact same thing. So 1/4, my first coordinate, 1/4 plus 2 is the same as 1/4 plus 8 over 4. 8 divided by 4, I'm using a common denominator because this is not going to be so that's going to become 9/4. So it's a little over 2. 1/2 plus 2 is the same as 1/2 plus 4 over 4, or 5/2. 1 plus 2 is 3. 2 plus 2 is 4. 4 plus 2 is 6. Wait, this is 2. 2 plus 2 is 4. 4 plus 2 is 6, okay? And then that's going to be my new function. If I were to plot these, I could get my new function. And all I should expect is that I've taken my baseline function and just shifted it over to the right 2 and up 2. So if it looked like this originally, I'm going to take this point, I'm going to move it over 2, and then up 2. And then that should represent kind of what my transformation looks like, ish. I'm not a computer, guys, but I'm working on that. Okay, I'm doing my best. Just doing my best. So let's try a new transformation. Let's say I had 2 times 3 to the negative x plus 1 minus 1. Okay? So here, the first thing I'm going to want to do is determine, well, what's my reference function? Where did I start here? And I recall that my reference function is y is equal to c to the x. And the c is always going to be the thing that has exponent. So 3, because 3 has the exponent, not 2, 3 has the exponent, my baseline function here is y is equal to 3 to the x. It's always going to be to the x, just figuring out what that number is. That is the exponential function. Okay? So now that I know that 3 to the x is my baseline, well, let's make my table of values. We can go ahead and do that. And I'm going to use the same range of x, my kind of go-to. And then let's go through it. 3 to the negative 2, I can rewrite as 1 over 3 squared, which is 1 squared over 3 squared, or 1 over 9. 3 to the negative 1, I can rewrite as 1 divided by 3 to the positive 1. I just flip it to get that exponent positive, and then it's 1 over 3. Anything to the 0 is 1, 3 to the 1 is 1, 3 squared is 9. Okay? Now, let's start pulling off all my transformations. A, I can clearly see is 2. And K, I can clearly see is negative 1. H is positive 1, so it's the opposite. It's negative 1. I'm moving left. And B is a negative 1, which 1 divided by negative 1 is still negative 1.
Mr. Vargas, can you call 3130, please, Mr. Vargas?
So when I'm going through and doing my transformations, I always do my stretches, my A and my B's first. I apply those first to both my Y and my X's, and then I add or subtract my K from my transformed Y coordinate, and I add or subtract H from my transformed B. So let's do that right now. Basically, all my Y coordinates, I'm going to multiply by 2 and then subtract 1. Y, so 2 times 1 over 9 is 2 over 9 minus 1. 2 over 9 minus 9 over 9. 2 over 9 minus 9 over 9. 1 over 9 times 2 is 2 over 9. And then I'm subtracting 1, but I'm going to use like the same denominator to do that. Minus 9 over 9, which is 1, gives me negative 7 over 9. So I get negative 7 over 9. 1/3 times 2 is 2/3. Minus 1 minus 3/3 is negative 1/3. So this becomes negative 1/3. 1 times 2 is 2, minus 1 is 1. Easy. 3 times 2 is 6, minus 1 is 5. Easy. 9 times 2 is 18, minus 1 is 17. Easy. Okay. And you can see this gets parabolic. It's growing in how much it increases by. So it's going parabolic. We're going exponential. Kind of like the coronavirus. Ooh, too soon? Too soon. Bad. Too soon. Okay. Now, I'm going to do my B's on my X. Oh my goodness. I was midway through this video, then my mom called. My mom called and that ended the video. So hopefully I can patch these together. Maybe I can fix this in editing. Okay, so where was I? I was talking about transforming my H's. So I'm going to multiply all of my X's by negative 1. Because that's going to give me my reflection in the Y-axis, multiplying it by negative 1. And then I'm going to subtract 1. Negative 2 times negative 1 is 2, minus 1 is 1. Negative 1 times negative 1 is 1, minus 1 is 0. 0 minus 1 is negative 1. 1 times negative 1 is negative 1, minus 1 is negative 2. 2 times negative 1 is negative 2, negative 3. Okay? So, my original function looked like this-ish. And then my reflection is going to, well, it's a reflection in the y-axis, so it's going to actually, and it's a stretch by a factor of 2, so it's going to be something like that. Again, I am not a calculator, okay? I can't imagine, but what I can do is come up with a table of values and plot it, okay? That is transformations. Now, let's do one more. Since I'm starting a video again for this from scratch. So, let's say I had y is equal to 1/2, 2, well, we'll make it to the negative 1/2, x minus 1 plus 3. Okay, my baseline function is 2 to the x. So I'm going to replace that c with 2 here. It's 2 to the x, and my table of values, when I go through it, negative 2, negative 1, 0, 1, 2, my table of values is 1/4, 1/2, 0, 2, 4. Okay? So, looking here, I'm just going to pull off all my numbers. A is 1/2. So I'm going to be halving all my y coordinates. And then I'm going to add 3. B is the number sitting outside the bracket, so it's -1/2. So let's see what that's going to do. I have a B of -1/2. And I'm going to divide, to figure out what I'm going to multiply all my x's by, I'm going to divide that by, I'm going to divide 1 by -1/2, and I get -2. So I'm going to multiply all my x coordinates by -2, and then I'm going to add 1. H is the opposite. H is the opposite of whatever sign we see there. So let's do that. So we'll do my x's first. I'm going to multiply them all by -2 and then add 1. -2 times -2 is 4, plus 1 is 5. -1 times -2 is 2, plus 1 is 3. 0 plus 1 is 1. 1 times -2 plus 1 is -1. 2 times -2 plus 1 is -3. Okay. And then y, I'm going to half all my y's. I'm going to multiply them by 1/2. So 1/4 times 1/2. And then I'm going to add 3. Is 1/8 plus 3. Well, let's use common. I can rewrite 3 as a fraction out of 8. Plus 24/3 is over 8. That's the same as 3. Now that becomes 25/8. So this is 25/8. All I did was I multiplied my y coordinate by my transformation, my stretch. 1/2 times 1/4, and then I added 3. But I added 3 using a common denominator of 8. So 24 divided by 8 is 3. The next term, 1/2, I'm going to times 1/2 times 1/2 times a is 1/4, and then I'm going to add 3 using a common denominator of 4. 12 divided by 4 is 3, and I get 13/4. And then I'm going to multiply 1 by 1/2, and I get 1/2, and then I add 3 is 7. And then I get -1/2. -1 times 1/2 is -1/2, plus 3 plus 6/2 is 5/2. And then -3 times 1/2 is -3/2, plus 3, so plus 6/2 is 3/2. And that, if I plotted that, that would be my function transformation. And I mean, we could go in either direction for the x's and y's, but I just chose a specific domain to see what it does. Now, a is 1/2, so I should expect that my vertical size, height of my function, which it goes from 1/4 to 1/4, should have been halved. So originally 4 minus 1/4, or 16/4, minus 1/4. My original function was 15/4. So if I were to half that, it should be something a lot smaller. So it's going to be half. So if I were to subtract 3/2, or 25 minus 3/2, so let's just friggin' do it. 25/8 minus 3/2. I'm going to turn 3/2 into a fraction out of 8. 2 times 4 becomes 8, so 3 times 4 is 12. This is 13/8. Which is pretty much close enough. It's the end of the day, I'm getting tired here. B, I should expect, oh no, so I was using, B, I should expect that I've actually stretched my width by 2 because it's 1 over that, it's 2. And if I look, my original function went from -2 to 2, it was 4 wide. My new one goes from -3 to 5 and it's 8 wide. So yes, I have in fact doubled it, and then I've shifted it over to the right, and I've shifted it up 3. Okay, that is exponential function transformations. I hope I can add these videos together. Thank you for watching, and thank you for dealing with my strange energy today. It's almost spring break, and I'm a little loopy. So We'll talk soon. The next lesson is going to be on actually solving exponential functions, and it's kind of fun, or exponential equations.